Okay, here are the solutions to the activity for section 2.5, which is the chain rule. There are a lot of problems on this activity. This is a big idea, so I've written out the solutions to most of them, but I'm going to walk through a couple of them step by step. So the first problem says find the slope of the tangent line to each of the functions at the given value. So here the function capital F is cosine of x squared. So here if we were to write this function as a composition of functions, f of g, little f would be played by cosine and g would be played by x squared. Then we'd take the derivative of cosine, which is negative sine, evaluate it at x squared, so that's the derivative of the outer function, evaluate it at the inner function. But because this inner function is x squared and not x, we need to multiply by its derivative. And its derivative is 2x, and so we get negative sine of x squared times 2x as the derivative of capital F. And we can rewrite that. It's negative 2x sine of x squared. I just changed the order of that product. It doesn't matter what order we multiply. And then we can evaluate that at the square root of pi over 6. And you should be able to show that that simplifies to negative root pi over 6 because sine of pi over 6 is 1/2. Okay, second example, capital G is cosine squared of x. So similar to I don't make very good G's. Oh, sorry about that. I wanted to rewrite G, not its derivative to start. Let's start by rewriting the function G. So G of x is just cosine of x squared. And now the outer function says raised to the second power, and the inner function is cosine. Okay, I'm going to do this one example again, writing this all out. G of x is f of little g, for f of x being raised to the second power and g of x being cosine of x. F prime of x then is 2x and g prime of x is negative sine of x. And the chain rule says take f prime evaluated at g. So g prime of x equals f prime, which is 2, evaluated at g. 2x evaluated at g is 2 cosine x. That's the 2 coming down, going to 1 less power. We can think of this as 2 cosine x to the first. The 2 came down, we went to 1 less power, and then we need to multiply by the derivative of g. We need to multiply by, sorry, I'll use the notation on the right. We need to multiply by g prime of x. And g prime of x is the derivative of cosine, which is negative sine. So we get 2 cosine of x times negative sine of x. And then we want to evaluate that at pi over 3. So g prime of pi over 3 is 2 cosine of, 2, oh, hey. Sorry about that. 2 cosine of pi over 3 times negative sine of pi over 3. I'm running out of space here. Let's see, cosine of pi over 3 is 1/2. And sine of pi over 3 is root 3 over 2. So that looks like negative root 3 over 2. Okay, third example. Okay, the outside function is raised to the 1274th power. So here we go. We take the derivative as if this is the power rule. The 1274 comes down. We leave the inside function alone. It's x squared minus 3. We raise to 1 less power, which is the 1273rd power. But because the inside function is not x alone, the chain rule says we need to multiply by its derivative, which is the derivative with respect to x of x squared minus 3. That derivative is 2x. And now we want to evaluate this thing to find the slope of the tangent line at negative 2. So we get 1274 times 4 minus 3 times negative 4. which is negative 5,096 is the slope of that tangent line. Okay. D, same thing. We have something squared. The 2 comes down, we go to 1 less power, we leave the thing inside parentheses alone, we multiply by its derivative is what the chain rule says. However, that derivative is going to require the quotient rule. So there it is. It's denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. We want the slope of that tangent line at pi over 2. So we put pi over 2 in there. Everywhere we see a t, and it simplifies to something that looks like this. So see if you can follow through the arithmetic there if you haven't already done that yourself. Okay, E gets a little bit trickier. Now, the outside function is tangent. So we take its derivative. The derivative of tangent is secant squared. We leave the inside function alone, which is cosine of sine of theta. But we need to multiply by the derivative of this inside function. So we need to multiply by the derivative of that inside function. Okay, so the first term, secant squared of cosine of sine, comes along. And now we're taking the derivative of cosine times sine. Okay? The derivative of cosine, now playing the role of the outside function, is cosine. We need the chain rule again here. The derivative of cosine is negative sine evaluated at the inside function, which is sine. But because that inside function is not just theta, we need to multiply by its derivative. The derivative of sine is cosine. So this gets here because it's the derivative with respect to theta of sine theta. It's the final step of the chain rule being applied twice. Okay, and we want to know the slope of the tangent line at negative pi. So everywhere we see a theta, replace it with a negative pi. Sine of negative pi is 0. Cosine of negative pi is negative 1. And we simplify to secant squared of 1 times 0. But I don't know what secant squared of 1 is, but if I multiply it by 0, I get 0. All right, here we go. Another chain rule inside of the chain rule. So the function is tangent of x to the 4th to the 3/2. So it's something raised to a power. So the power comes down with the power rule. 3/2, the thing inside stays. Tangent of x to the 4th. We raised that to the 1/2 power. But then we need to multiply by the derivative of the thing inside. So the derivative with respect to x of tangent of x to the 4th. So now, in this second step, playing the role of the outside function now is tangent, and the inside function is x to the 4th. The derivative of tangent is secant squared, evaluated at the inside function, which is x to the 4th, and 4x cubed is the derivative with respect to x of x to the 4th. It's the last step in the second application of the chain rule here. Chain rule leads us to the derivative of tangent x to the 4th. We use the chain rule again to find its derivative. And we're curious to find the slope of this tangent line at the 4th root of pi over 4. So we evaluate everywhere the 4th root of pi over 4, and that thing should simplify to 3 pi cubed over 16. All right, number 2. Find the equation of the tangent line to h of x is x cubed minus 4x squared plus 4 to the 11th power at x equals 1. Okay, so equation of the tangent line. We need a point and a slope. Let's find the point first. It's 1 comma h of 1. What is h of 1? It's 1 minus 4 plus 4 to the 11th power, which I guess is just 1. So our point is 1 comma 1. Now to find the slope of that tangent line, we need to take the derivative. So h prime. What is it? Again, we have something raised to a power. The power comes down. We treat the something as if it's just something, as if we're just applying the power rule. But because that something is not x, we need to multiply by its derivative. And so we can do that. So h prime is 11 times x cubed minus 4x squared plus 4 to the 10th times the derivative of x cubed is 3x squared. The derivative of negative 4x squared is negative 8x, and the derivative of 4 is 0. And we want to know the slope of that tangent line at 1, so h prime of 1 is 11 times 1 minus 4 plus 4 to the 10th times 3 minus 8. So let's see, that looks like 11 times 1 to the 10th, that's 11, times negative 5. 11 times negative 5 is negative 55. So we can write down the tangent line. It's y minus the y coordinate of our point, which is 1, is equal to negative 55 times x minus the x coordinate of our point, which is also 1. Okay, last problem on this activity. Find the equation of the tangent line to f of x equals 1 over the square root of x cubed plus 2x plus 1 at x equals 1. Okay, at first glance, that might look like something where we have to use the quotient rule, and that would imply the chain rule inside of the quotient rule. But if we think about doing a little bit of algebra first, we can avoid using the quotient rule here. So we can just start by rewriting f. It looks like x cubed plus 2x plus 1. Well, that's all being raised to the 1/2 power, which is in the denominator, so that means it's the negative 1/2 power. Now we can go ahead and use the chain rule directly. We have something raised to a power. That power comes down, that's the negative 1/2. We raise that something to 1 less power, which is negative 3/2, and then we multiply by the derivative of that something. So the derivative of x cubed plus 2x plus 1 is right here. It is 3x squared plus 2. Okay, so now to write the equation of our tangent line, as always, we need a point and a slope. The point comes from evaluating the original function at 1. When we do that, we get 1/2, so our point is 1 comma 1/2. The slope comes from evaluating the derivative at 1. When we do that, we get negative 1/2 times 4 to the negative 3/2 times 5. So here is 4 to the negative 3/2 on the side, in case we need some practice with fractional exponents. 4 to the negative 3/2 is the same thing as 4 to the 1/2 raised to the negative 3rd power, because we multiply the exponents. But we know that 4 to the 1/2 is just the square root of 4, which is 2. And 2 to the negative 3rd is 1 over 2 to the 3rd. And 2 to the 3rd is 8. So that thing simplifies to 1/8. So f prime of 1 is negative 1/2 times 1/8 times 5, which is negative 5/16. And there's our tangent line. Y minus 1/2 is equal to negative 5/16 times x minus 1. Okay, see if you can go to the textbook and work on the 2.5 problems that are assigned related to the chain rule.